In continuation of the previous video, when we want to do the assignment more formal and documented, we should do this. We write 0 to 0.75, the value would be 10, and 0.75 to 1, the value would be 15. So it's going to be the reference table for simulation. So what are you going to do here? You are going to generate a random number with rand function, and it generates a number. For example, it is uniformly distributed between 0 and 1. For example, it generates 0.33. In this situation, what is the random number? In fact, it is 10, because 0.33 belongs to this range, and the associated value to this range is 10. And see, since the length of the range associated with 10 is 3 times of the length of the range associated with 15, 10 would appear on average in number 3 times of 15, and makes sense. And it says the probability of 10 is 75%. Out of 4 cases, 3 of them should be 10. And in this situation, you will have it. But very soon, we are going to have some more activities on that, and you will learn it better. So in the case of the Sanatronics that we have, the associated table documentation is like this. The table illustrates the process of partitioning the intervals from 1 to 0 into subintervals so that the probability of generating a random number in a subinterval is equal to the probability of the corresponding direct labor cost. So it is talking about the Sanatronic case that we had. See, in the Sanatronic case that we had, as you can see in front of you, we discussed it last session in one of the activities. The direct labor cost followed discrete probability. And in the previous case, in the previous slide, we had 2 values, 10 and 15. But here we have 1, 2, 3, 4, 5 values, 43, 44, and here are the probabilities. As you can see, the probability of 43, the direct labor cost become 43 is 10%. But the probability of 45 is 40%. So according to the things that we discussed, the length of assigned interval in the range 0 to 1 must be 4 of length of 43. And here you can see for 45 it is 0.3 to 0.7, so the length is 0.4. But for 43 it is 0 to 0.1, the length is 0.1. So when you get the probabilities and you get the concept, it's very easy to create these intervals, because you know the range starts from 0. So you start it very easily, like this that I'm doing here. I'm going to do it here. So for this one, it starts from 0 because it is ran, and you say between 0 to 0.1, and 0.1 is not included. It would be 43. And when you continue with the upper bound of the previous one. So you say from 0.1, what is the length of probability? It is 0.2. So 0.2 plus 0.1, it would be 0.3. And why the length of 44 is twice the length of 43? Because the probability of 44 is twice probability of 43. We continue like that. We start from 0.3 and the probability is 0.4. So 0.4 plus 0.3 would be 0.7. After that, we start from this, and like this you continue. And now I exactly show you step by step how you get these values that you see on the right. So to create any sort of discrete distribution, first you sort the values: 43, 44, 45, 46, and 47. In the previous slide, we had only 10 and 15. We sort them. After that, you check the probability. And since the probability has direct relation to the length of the assigned range on 0 to 1, so you just simply add the probability to the upper bound of the previous range. Here, since 43 is the smallest one, so the lower bound would be 0. Start. The length is that, so you can start with this. For 44, you get the upper bound of the previous one, that is 0.1 plus the probability, so you get 0.3. And like that, you continue. And for the last one, you get to 1. And now you would have a very good understanding of the second rule here that says when we add up all the assigned, why all these EDs are missed here? Okay, rule 2, when we add up all the assigned ranges, they must be of length 1. Here, if you add 0 to 0.75 to 0.75 to 1, okay, the length would be 1. And here, when you add all of these ranges together, 0 to 0.1, 0.1 to this, and all of them, when you add all of these things together, the result, the range is 0 to 1. Makes sense? Okay, now you are ready to do the activity related to discrete probability distribution. Now try to do this activity. This activity is very similar to the discussion that we just had. It is the same, just with different numbers to make sure you got the point completely. So pause the video before you see the answer in the following seconds. Okay, here is the answer for that. According to the things that we discussed, we start from the smallest value, that is 43, and 0 is the start on the ranges, because the function ran generates a random number between 0 and 1. So since the probability is 0.1, we have here the range of 0 to 0.1. After that, for 44, we have 0.1 to 0.2. It is 2 here, 0.2. So the start is 0.2 to 0.4, and like that you continue to get the results like this. Okay, the last step that we need, the last things that we need to know to generate a random number, and also I referred to it before. Here you can see how to simulate discrete probability distribution, but the second slide or second description, the related slide, like many of the other things that we had today so far, is vocal. You can check it on your PowerPoint, and also I'm going to explain it here, that what is the point that is considered as the final point regarding generating a random number. When you have this table, okay, the only things that you need to add to generate the random number is considering another column that is random number between 0 and 1. Okay, let's generate a random number. For example, I run the command and the random number that I get is, for example, 0.27. 0.27. Then I get 0.27. What is the related random number? Okay, when it is 0.27, I should go and find the ranges and see this 0.27 belongs to which range. Okay, here no, because it is greater than 0.1. Here no, because it is, let me, okay, here now you can show the arrow. Okay, here it doesn't belong because 0.27 is greater than 0.1. Here no, because it is greater than 0.2. Here yes, 0.27 belongs to this range because it is greater than 0.2 and smaller than 0.4. So what would be the generated random number? Okay, and now the generated random number that is equal to this is 45. So you just simulated direct labor cost and you generated a discrete random number according to this table. You got 0.27, so now we got $45 for the year that you get the random number of 0.27. The associated the discrete number is 45. Let's do it another one. For example, we generate another random number and we get, for example, 0.97. 0.97. We check and we notice it belongs to this range, the range with probability of 0.3. So the associated one is 47. And like that, we continue. So it would be, oh, what happened to color? Okay, it would be 47. We ran this simulation model 2 times. So for the first year, for example, we got 45, and for the second year, we got 47. It is the main points that is discussed here, and now you are good to do a simulation model regarding the cases you are given. In activity 4, you are asked to do the same challenge as normal distribution and uniform distribution. So it asks you regarding the Sanatronics case, create the associated random numbers. I have put the case here for you to have easier access to the information. Okay, it asks you for the case of Sanatronics described before, that is here. Simulate the direct labor cost per unit 1,000 times. Here you have the probabilities, and here is the description of the case. Sanatronics believes that the direct labor cost will range from 43 to 47 per unit, and the probabilities are like this. Obviously, it is discrete distribution, and because Sanatronic models the direct labor cost per unit with a discrete probability distribution, the direct labor cost per unit can only take one value because it is discrete.